Welcome to our video, which will show you how to set up and carry out the GCSE Chemistry required practical for identifying ions. In this practical, students will carry out a range of tests on some known samples. They will then use their knowledge to identify the ions in an unknown compound. For this practical, you need a range of different chemicals which are then made up into solutions, and the full list of chemicals that you need is available on our website. You also need some test tubes, a test tube rack, flame test loop, spatula, Bunsen burner and heat-proof mat, a pipette, and of course a set of safety goggles. The first test that your students will carry out is a flame test. So they need to set up a Bunsen burner on a heat-proof mat, and they need to write the names of the chemicals they're going to test on the test tubes. They will then transfer some of each solution into the test tube. 1 centimetre depth of each will be enough, and they need to make sure that they use a different pipette for each solution so they don't cross-contaminate each of the solutions. Students first of all dip the nichrome wire into the first solution they're testing and turn the Bunsen burner flame to the blue flame. They then put the loop into the flame and observe the colour of the flame and write it down in their results table. Students then need to burn off the rest of that sample to clean the loop before they use it for the next sample. Students then repeat the test by dipping the nichrome wire in the next sample, turning it back to the blue flame and noting down the flame colour, and they repeat this with all of the other samples that they're going to be testing, remembering to burn off the sample from the loop in between each of the tests. Next, your students could do the test for carbonates. So for this test, they'll need some hydrochloric acid. I've just poured a small amount into a beaker. They need the carbonate solutions that they're testing, and in the final test tube, I've got some lime water. So we get a small amount of the hydrochloric acid and add it to the first solution. And if bubbles are made, you collect the bubbles of gas with the pipette. Now the gas generated will be carbon dioxide, and that's quite a dense gas, so it will just sit on top of the solution, and then we transfer that into the lime water. And if you do that a few times, before long, the lime water should turn cloudy or milky because of that carbon dioxide that's being generated. So there we can see the lime water has now gone milky. Next, your students could move on to the test for sulfates. So for this, I've got some barium chloride that's been made into a solution, and I've got the different solutions I'm going to test. Before we add the barium chloride solution, we add a few drops of hydrochloric acid to the solution we're about to test. And then we add a few drops of the barium chloride solution. And if it's a sulfate, we get a white precipitate. The final test for your students to carry out is the halide test. So for this, they'll need some nitric acid, some silver nitrate solution, and I've got here some sodium chloride, sodium bromide, and sodium iodide solution. It's important for your students to see all three because they are quite similar colours, so they need to compare them to each other to notice what the differences are. So first, your students would add a few drops of the nitric acid. And then we're going to add about 1 centimetre depth of the silver nitrate solution to each of the solutions. Each of the halide solutions produced a precipitate when we added the silver nitrate solution, but the colour is slightly different for each one. Chloride gives a white precipitate, bromide gives a cream precipitate, and the iodide gives a yellow precipitate. Now that your students have completed their test on the known samples, they then repeat the test on the unknown sample. Can they identify the positive metal ion? Can they also identify the non-metal ion? We hope you found our practical advice useful. For expert technical support, please contact the Philip Harris Technical Support Team on tech support at philipharris.co.uk or visit our blog at philipharris.co.uk/blog.